a closed system known as a control mass consists of a fixed amount of mass and no mass can cross its boundary. But energy in the form of heat or work can cross the boundary, and the volume of a closed system does not have to be fixed. If, as a special case, even energy is not allowed to cross the boundary, that system is called an isolated system. An open system, or a control volume, as it is often called, is a properly selected region in space, but it represents the typical fluid flow condition that we want to consider, analyze, and discuss. It usually encloses a device that involves mass flow, such as a compressor, turbine, or nozzle. Flow through these devices is best studied by selecting the region within the device as the control volume. Both mass and energy can cross the boundary of a control volume. A large number of problems involve mass flow in and out of a system and therefore are modeled as control volumes. These things are important, and even developing for continuity equation, for momentum equation, and so on. So we always start by considering a control volume, its movement or movement of the fluid within that volume. A water heater, a car radiator, a turbine, and a compressor all involve mass flow and should be analyzed as control volumes. Open system or control anyway, whether they are open or closed, but control volumes instead of as control masses. When it comes to control masses, they are closed, while the control volumes are open. In general, any arbitrary region in space can be selected as a control volume. So that's why we choose any. It's very arbitrary in nature, but it should be typical and it should be representing the fluid correctly. There are no concrete rules for selection of control volumes also, but the proper choice certainly makes analysis much easier and also much realistic. If you want to choose a realistic analysis, you have to choose the right the real fluid flow conditions. If we were to analyze the flow of an air through a nozzle, for example, a good choice for control volume would be the region within the nozzle. So that is an option. A control volume can be fixed in size and shape, and in the case of a nozzle, or it may involve a moving boundary. Most control volumes, however, have fixed boundaries and thus do not involve any moving boundaries. A control volume may also involve heat and work interactions, which we said as whether if it is heat or work, then there are different forms of energy that is involved, and they can be considered in the control volume as well, in addition to the mass interaction that takes place when heat and work are in consideration.